Okay, so Isaac Newton, right? Uh, Now, a little bit of context. Actually, he was born on Christmas Day. He was kind of a, I guess you could say, weirdo. Really, he didn't have an awful lot of close friends. A lot of people think he very possibly was autistic, but still incredible genius, right? And so, definitely on the spectrum, right? Um, he actually born the same year Galileo died. So that gives you perspective. Memorizing dates isn't really, what I'm after here. But he was born like in the middle 1600s and died like 1624. Okay, so or 1724. So again, this was before the American Revolution. We're talking late 1600s was when this was going on, early 1700s. Okay, so remember now the situation before Isaac Newton, there was a big debate going on. Actually, most people didn't even know about this debate. They were just like digging in the fields to plant their crops. They were just going about their lives, the peasants and stuff. But the educated people had this debate going on, and it was a debate about the geocentric versus the heliocentric model. Remember that vocabulary. Geocentric means what? Say it, think it, recall that word, geocentric. Geography, geology, geo means earth. It's earth-centered. And heliocentric, helios is the name for the sun. Sol or helios are two different names for the sun. Heliocentric means sun-centered. We now, as a science teacher, we teach the heliocentric model. This is the one that won out because it's a better model of how the world actually works, or I guess I should say the cosmos works, the solar system. It turns out that is truer than the idea that the Earth is in the center. But it looks like it's in the center. It feels like it's in the center because everything's moving around us. Well, and we can't feel that motion. So here we have Aristotle's universe where the Earth is in the center, right? And then you got the planets, and there's the sun going around the Earth. Okay? Now, the heliocentric model, the one we now teach in science class that we've accepted, and because it's true, the sun is in the middle, and the Earth goes around the sun. So this is the revolutionary idea of the heliocentric, which, by the way, Copernicus is the guy who first discovered it, and the name of his book is Revolution of the Spheres. That's where the term revolutionary comes from. So write this next part down. Here's the first bit of notes. It's Newton settled the sun-centered controversy by explaining how it works. Go ahead and write this down. If you need to pause the video to have enough time to write it down, go ahead and do that. But people were like, this is crazy that the Earth is moving. The Earth is like the only solid thing there is, unless there's an earthquake or something. Rivers move, the wind blows, we walk around on it, but the Earth stays stationary, right? But how could the Earth be moving? Well, he explained how the orbits work and why we don't feel that motion. Okay, we're going to do some Newtonian physics here. We're going to come back to it later on, majorly studying all the laws of physics that Newton discovered, the laws of motion. But two of them here. Galileo, he invented mechanics. So he was a great scientist, right? He invented this science of mechanics of how things move. And he discovered that, heavy and light things fall at the same speed. Isaac Newton devised the laws of motion. There are three laws of motion. We're not going to really get into one today, but there's three of them, which we will get them all three later. And gravity. You've heard of the law of gravity? Isaac Newton is the guy who discovered the law of gravity. In fact, it's not unreasonable to say that Isaac Newton invented the law of gravity because it was the explanation for how things work. Okay, so you have that written down, the laws of motion and gravity. So we got to talk about those a little bit. I think we'll do the law of motion first. There's three laws of motion. The first law is that an object in motion stays in motion unless acted upon by a force. Okay? I'm going to have you write that down in just a moment. But what that means is, remember I was saying before that in Galileo and Isaac Newton's time, people figured unless something's pushing it, things can't be moving, right? In fact, they even used that as proof that there's angels in heaven because something has to be pushing the planets around in their orbit. Well, anyway, is how can something be moving unless something's pushing it? And remember, from their perspective, yeah, if you got a wagon with wheels and stuff, it's gonna not move unless the ox is pulling, right? But Isaac Newton, he discovered that's not really true. You have certain like air resistance is one thing we've already kind of dealt with, but we have like friction on the earth. That the ox cart's hard to move because it's got to roll against bumpy and getting stuck in the mud. But an object in motion stays in motion unless acted upon by a force. Instead of it being a force has to be constantly applied to it, once a force is applied to it, it will keep on moving by itself unless another force is applied to it. An object in motion. Okay, so the ball's in motion, right? Now, I applied force when I threw it. When I tossed it, I applied force. But does that mean do I have to push it the whole way? No, I don't have to push it the whole way. Once it's moving, it just keeps moving on its own. It's just the law. It just keeps on moving. Things keep moving unless a force is slowing them down, right? So, if you throw a baseball, the pitcher doesn't have to push it all the way to home plate. If you fire an arrow, the string doesn't have to push it all the way to the target. Once it's moving, it keeps on moving. That's the first law of motion, okay? So the object in motion stays in motion unless acted upon by a force.